Okay, so this is the second half of our unit. We have different sections. Writing equations is a big portion of it. Given a point and the slope, given 2 points, parallel and perpendicular lines. So I'm going to do as much as I possibly can, but we are going to skip around a little bit. They all have the same format. That is what makes it easier. So if you guys remember, we used point slope form and we use slope intercept form. Most of you preferred using slope intercept form, so that's what I'm going to do the majority of the time. Okay, I am going to do one example of each to get us started. So when you have to write the equation the slope intercept form and you're given the slope and an intercept, or slope and a point, I'm sorry, you can plug that information in here. So we would have y minus 7 equals x minus a negative 2, so it turns out to be plus 2. Now, if you don't like this method, don't worry. I'm just doing one problem like this to refresh people's memory. The nice thing about this method is that you don't have to substitute b back in, okay? So we can approach this problem distributing that negative 6. Negative 6 times x is negative 6x. Negative 6 times a positive 2 is a negative 12. Then your last step is just to move that 7 over by adding it. Y equals negative 6x. If this confuses you, negative 12 plus 7, you can throw that in your calculator. You're going to end up with a negative 5. And that's your answer. So some people really like this method, and I do too. You don't have to worry about putting that back in, but people do make errors when they distribute, and that's why most people don't stick with that method. So I'm going to use the other method, the y equals mx plus b. This is your x and your y. This is your m. So negative 3 goes in for your y. Negative 3/2 go in for your m. 4 goes in for your x. And we do not know what b is. That's what we're looking for. We are going to simplify. 3/2 times 4 gives us 12 over 2, which gives us a negative 6. Now always use that calculator to check your math if you're unsure. Then to get b by itself, we are going to add 6 to both sides. Negative 3 plus 6 is 3. So your equation, then we have a slope of negative 3/2. We have a b of 3. So our equation, you put the 3/2 in for your m, your 3 in for your b, and that's your answer. Okay, I'm going to jump down to the next 2 problems. The reason why these are different is because we're not given the slope. We have to find the slope. So find slope first is why these are different. x1, y1, x2, y2. You can use either method. It doesn't really matter. So I'm just going to do these really quick. M equals 11 minus 7 over 2 minus 1. 11 minus 7 is 4. 2 minus 1 is 1. So that simplifies to a 4. Yep. Now like I said before, you can use either method, and guess what? You can use either point. I like to choose positive, smaller numbers if I can. Okay, so I'm going to use the 1 and the 7. The 7 is going to go in for y. The 4 goes in for your m. The 1 goes in for your x. And we do not know what b is. Again, if you like the point slope form, go ahead and use that one. That's fine. So this gives me 4 times 1 is 4. And then we have to solve to get b by itself. So I'm going to subtract 4 from both sides. So on this one, my slope is 4. My intercept is 3. So my equation is 4x plus 3. you want me to do another one of those?
No.
Okay. So now we're going to move on to those parallel and perpendicular lines. So what is the slope of this line right here? 1/2. What is the slope parallel to this line?
1/2.
1/2. Parallel lines have the same slope.
I remember that.
Okay. Now perpendicular though, what are we going to do?
-2/1.
-2/1. Okay. So we're going to do one problem. It says find the equation of a line parallel to y equals 1/2 x plus 5 passing through this point. So guess what? They're giving us the slope and they're giving us a point. Just like we did in these problems up here. No different. You just have to be able to take the information. Parallel lines mean you're going to use the slope. So we're going to put x, y, and m.
So you always use the same.
If you're asking for parallel, you use that m. If we're doing perpendicular though, we're going to flip it over.
But you use the same, like, whatever these are called.
Yep, the coordinates, yep.
Yeah.
So we're going to put 6 equals 1/2 times -4 plus b. 1/2 times a -4 is a -2. And then to get b by itself, we just add the 2 to both sides. So again, we found our intercept. They gave us our slope. So then you just write your equation, y equals 1/2 x plus 8. Now I am going to do a perpendicular one because when it's perpendicular, we have to look at the slope. The slope is 1/2. But when it's perpendicular, what happens to our slope?
It's negative.
-2 or -2/1. This is still our x and our y. We're still going to follow the same exact steps. So our y is 8. Our slope is -2. Our x is -2. And we're solving for b. So -2 times -2 is a +4. And then how do I get b by itself? You just subtract that 4, yep. 8 minus 4 is 4.
Why
So-
would you subtract?
Because I wanted to get b by itself, so I moved the 4 to the other side.
Huh?
This is 4 plus b, and I need to move the 4 to the other side, so I have to cancel it out by subtraction. So here's my slope, and here's my b.
But why wouldn't you do that for the parallel one?
I did. I just moved the 2 over by adding, because it was a -2. I solved them in the exact same way, they're just different values. So the slope is a -2x plus 4, and that's your answer. So I'm not going to do the next one, but we are going to look at the slopes just for practice. So what is the slope of this line right here? Y equals -4x minus 7.
-4.
Yep, and what's parallel to this line?
-4.
Yep, so same slope as a -4. What about perpendicular? 1/4, so it's flipped and it's positive.
So there's 2 steps.
Okay. Okay, so now we're gonna flip because this is the most recent stuff. The first is transformations. Okay. So one thing I want you guys, before you look at transformations, can you predict the changes?
No.
So for example, if I look at 2 equations, I look at what changed. Was it the slope, or was it the y-intercept, or was it both? Okay, on this one, what changed? Was it the slope or the y-intercept? The y-intercept. So that means that the slope stayed the same and it just shifted, moved up or down. Okay, so let's graph these. The first one is just a parent graph of, starts at 0, and then it goes up 1, over 1, up 1, over 1.
I still don't understand.
You might want to do that before your test. Okay, so here is my line. And I always throw a label on them so you don't get confused. That's my f of x. And my other one, it starts at +3, which we kind of predicted that the y-intercept is going to be different, but the slope is still the same. Up 1 over 1, up 1 over 1. Okay, so if that's the case, this is my g of x. If the slope didn't change, it did not reflect and it did not rotate. This is called a translation, which is a slide. And so you tell me that it's a translation. But you have to tell me, did it go up, did it go down, and how far? So we always look at our y-axis. So did it go up or down?
Down.
Well, it went from the pink one, which is f of x, to the green one that was g of x. Yep, it went up. So it was up, and how many units? 3 units. Okay. Now the next one, did the y-intercept change? Well,
Yes.
it's, nope, but they're just plus zeros. Remember, if there's nothing there, it's just a +0. So the y-intercept did not change. Did the slope change? Yep, it went from a +4 to a -4, okay? So if it went from a +4 to a -4, that means it reflected because it's opposite. So the first one, I start at 0, up 4 over 1. Okay, that's my first graph. My second graph, it starts the same place, but I go down 4 over 1. Okay. And then if they are the same slope but opposites, this is a reflection. Okay. Now the last one here, not only was our slope different, but our y-intercept changes. So 2 different transformations happened here. So I'm going to graph the first one. The first one, I started at +1, and my slope is up 1 over 2, up 1 over 2. Then my second one, I start at -4. So is it starting at the same place? No. So did it go up or down?
Down.
Okay, so right now we know it went down, so it's a translation. And then this is an up 4 over 1 slope. 1, 2, oops, should have went down one more. 1, 2, 3, 4 over 1. Okay, did this get more steep or less steep?
More.
It got steeper, okay, so very good. So this is a translation because it went down 5 units. And you can count those 5 just by going from that pink dot to that blue dot right there. But it also rotated. The rotation, and you have to tell me, did it get more steep or less steep? This one got steeper. Okay, so 3 different types: translation, reflection, and rotation. Okay, the last type of problem were linear inequalities. So I'm just going to probably do one of these, and then I'll try to graph as many as we have time for. To tell whether the ordered pair is a solution, you put the ordered pair into the inequality. So for example, this is your x, this is your y. 3 goes in for y. 0 goes in for x. Is 3 less than or equal to 3? This is kind of tricky, but is 3 less than or equal to 3?
Yeah.
It's equal to, yep. So because it has this equal to sign, that makes it true. And if it's true, that means yes, it's a solution. Maybe I'll try to do one more here. X, Y, 1 goes in for Y, -2 goes in for X. 2 times -2 is a -4. -4 plus 4 is 0. Now, is 1 less than 0? Less than or equal to? No. So if this is false, it's not a solution. Okay. Now we learned how to graph these. This is like the same slope-intercept form that we've been graphing. We start at +1. So just kind of ignore the inequality for a moment. And then our slope is 1/2. So up 1 over 2, up 1 over 2. Now, when I make my line, I do have to know, is this going to be a solid or a dotted line? Do you guys remember? It's going to be a solid line because it has the line underneath it. So that's a solid line. And then I have to decide, is this going to shade above or below? Well, Y is less than, so we are shading below. Okay. Let's do the next one. We're going to start at +3. The slope is a -2. Remember, if it's a whole number, we put it over 1. So I go down to right 1, down to right 1. Is this going to be a solid or a dotted line?
Dotted.
Dotted. So I make a dotted line because that inequality symbol does not have a line underneath it. And it says Y is greater than, so do I shade above or below? Above. Okay. Now the last one is a little bit different, only because Y is not by itself. So I could do that really quick by dividing by a 2. I have Y is less than or equal to 2x minus 1. So I start at -1. I go up 2 over 1, up 2 over 1. Solid line or a dotted line? Solid. Okay. And then it says Y is less than, so do I shade below or above? Below. And that is those.